projected global warming impacts actually get discussed a lot in the general media as well, especially when extreme events happen. The headlines typically follow with what the IPCC report says about such events, whether it's cyclones or heavy rainfall and flooding or sea level rise impacts and so on. We'll still go through them a little bit. So this is about difficulties with aligning specific levels of global warming with impacts. So what level of warming leads to what? So uncertainty in regional climate change, additional drivers of change that we looked at associated with greenhouse gases, and the changes in vulnerability itself, which relates again to the disparities in the climate impacts and so on. So this top-down kind of approach we already looked at, greenhouse gas concentration leading to 2-degree warming, let's say. And what does it mean for a local climate? Global mean 2-degree warming. What exactly does it mean for your backyard? That's not always easy. There are lots of uncertainties, but nonetheless they have local biophysical impacts. So there are non-climate effects of greenhouse gases there, and those create socio-economic impacts which result in changes in vulnerability. Okay, so relating regional climate change and its impacts to global mean temperature rise is very critical for adaptation. The timing and rates of change, especially in the relation to economic changes which affect vulnerability, are going to be important. The adaptation and the adjustment to changes is going to be difficult if changes come very rapidly. Right? If you go from a temperature of 25 degrees, which is okay for, let's say, some crop you're growing, and it very rapidly in a few years increases to something that's not suitable for the crop anymore, you don't have time to plan, to find alternative crops, to find the resources to switch or to move and do another job, and so on and so forth. So these rates of warming and timing are going to be very important. Dealing with the drivers of change that are connected to climate change, but with a large uncertainty in how they relate to global mean temperature change. So you have global warming, local impacts, biophysical and biogeochemical, feeding back to global mean temperature change. These obviously we looked at already, but the uncertainties have to be tracked and somehow incorporated into the projections. So CMIP 5 has gone into this dangerous anthropogenic intervention, which is attempted to be defined in this way. It's looking at systems that are risks to unique and threatened systems. I will show a table next. Frequency and severity of extreme climate events, global distribution and balance of impacts, total economic and ecological impacts, risk of irreversible, large-scale and abrupt transitions. Obviously the collapse of Greenland glacier or some particular Antarctic glacier are clear examples. There are also other things mentioned like collapse of the Amazonia and so on, but actually none of the models are capable of telling you very reliably what are the probabilities of hitting these, even though there is a cottage industry of talking about tipping points and how imminent they are and so on, but they are heuristic arguments not coming directly out of model dynamics. Okay, so I would be careful about those. So here are future temperature increases and time horizons over which risks are shown, obviously increasing risks this way. So in 1990 baseline, if you looked at these systems, there was risks to some. It was already increasing in frequency and severity of extreme climate events. It was negative for some regions in terms of global distribution and balance of impacts and so on. So this is a way of trying to give you a stratified information on these systems in terms of what the warming would mean in terms of risks going from very low to higher and very high. Okay, so this is a range of future scenarios and uncertainties where the risks of future uncertainties are shown here. Okay, so the 5 RFCs defined here. Unique and threatened ecosystems. So there are some ecosystems and cultures. I won't go read the details, but you can. This is directly out of the IPCC report. Extreme weather events, we already know what that means. So with 1 degree C additional warming, risks are high, but we say this with medium confidence. Risks associated with some types of extreme events like extreme heat increase progressively with further warming. Okay. Distribution of impacts, what does that mean? So risks are unevenly distributed between groups of people and between regions. We already looked at global south, global north, some agricultural productions in cooler climates benefiting from global warming, while as decreasing in warmer regions, and so on. So risks are generally greater for disadvantaged people and communities everywhere. Risks are already moderate because of regional differences in observed climate change impacts that are already manifest. Warming has been accelerating since 1980 or so, particularly for crop production. The confidence on this is medium to high. Based on projected decreases in regional crop yields and water availability, risks of unevenly distributed impacts are higher for additional warming above 2 degrees centigrade. So there are global aggregate impacts, and there are large singular events. Again, as I said, sea ice collapse in the Arctic and Arctic ecosystem is one that has to be watched very closely. That's going really fast, especially because of the polar amplification. Risks increase at a steepening rate under additional warming of 1 to 2 degrees and become high above 3 degrees centigrade due to the potential for large and irreversible sea level rise from ice sheet loss. So this is something we have to consider, because ice sheet loss, as we said, goes very fast in the warming phase because of the ice albedo feedback. But no amount of mitigation and adaptation is going to rebuild the ice sheets in human timescales. That takes a very long time. That's almost like a geologic timescale process. We looked at the ice ages and deglaciations, or even the Heinrich events and Dansgaard-Oeschger events, stadial interstadials, are on century and millennial timescales with some decadal abrupt changes, like the Younger Dryas. Okay, so that's definitely something we have to watch out for. So I will leave this for the next podcast, because this is about how to compute the net effect in terms of CO2 equivalent, starting from let's say the Industrial Revolution. Okay, the impact has to be looked at in terms of greenhouse gases and non-greenhouse gas and other impacts, but just converting all greenhouse gases to CO2 equivalent is also not always that straightforward, because it depends on whether you've been tracking emissions since Industrial Revolution or looking at concentrations in the atmosphere, because concentrations in the atmosphere are a net effect of the carbon cycle in the Earth system, whereas emissions are just human activities burning fossil fuels and others like land use change, transportation, etc. Right?